In this video, we're going to see how to solve systems of inequalities. One of the big differences between systems of inequalities and the equations that we solved before is that there are going to be infinitely many solutions to these inequality systems. As a result, we can't just solve and get x equal to 5 or something like that. We cannot list the answers. The best way we have to say what the answer is to shade on our xy axis here which points are solutions and which ones are not. So here's the general process. In this particular system, we have two equations here. In this case, they're both linear equations. It's going to make our life a little bit easier here. And what you're going to want to do is you're going to want to graph each of these lines. So y equal to 2x plus 1, that's a line whose y-intercept is 1 and whose slope is 2. So it's going to look something like this. Then our second line here is a line with a y-intercept of -2 and a slope of -1. It's going to look something like this here. And then we need to shade in which parts are actually going to work. Now there's a couple ways of doing this. One way is to pick a point that's on either side of your line. For example, you can pick any point you want to. Oftentimes we'll pick 0, 0 because it's easy. So if I go ahead and pick 0, 0, and I look at my first equation here, and I plug in 0, 0, I would have 0 is less than or equal to 0 plus 1. And so that is true. And what that means, if you ever get a true statement, that means the side that has that point is the side you want to shade in. So that right there would be the solution for the first line. It's not the overall answer to the problem. Next, we need to go ahead and take another point and try for the red line here. Now you can use 0, 0 again, but I want to show you what happens when things don't work out so nice, so I'm going to pick a different point. I'm going to pick this one right here, which is -1, 2, 3, 4. So I'm going to pick the point -4, 0. So that means I plug in y of 0 and an x of -4. And this would end up reading 0 is greater than 2, which is a false statement. And whenever you get a false statement, you do not shade the side that you were on for the point, you shade the opposite side. So I would go ahead and shade that side, the one that's not including the point -4, 0. However, because this is a system of equations, we're looking for points that work for both red and blue. So that means we want the overlap here. The purple is where our answer would be. And there's one last thing to concern yourself with. If you have a less than or equal to or a greater than or equal to, that means points that are on that line are good to go, no problems. But if you have a strictly greater than or a strictly less than, it means points that are on that line do not actually work. And so what you have to do is you have to put a little dotted line there. And this will indicate that the points that are actually on the edge there don't actually satisfy the equation. And so if I wanted to write out my final answer here in a nicer fashion, I would have something like the following. The blue line was solid, the red line was dashed, and this purple part here was the actual answer to the problem. So that right there would be the final solution that I'd be looking for. The thing is not every system of inequalities is going to have just lines. On this bottom one here, we have y greater than x. That's a line. And it's just a regular line y equal to x, and it's going to be a dashed line because it's strictly greater than x. Now, in this case, the line actually goes to the point 0, 0, so I cannot use 0, 0 to test. You can pick any other point that's not on the line, though. For example, if I were to pick 0, 2 here, so I go ahead and plug in y is 2 and x is 0, that's a true statement. So I go ahead and shade in there. The second one, however, this is not a line, this is a circle, right? X squared plus y squared is 4 is a circle with radius 2. So sometimes you could have circles, occasionally you might have a parabola. On the hard ones, maybe an ellipse or a hyperbola. But you might have a little bit more complicated shapes like that. Now a circle of radius 2, you have to go out 2 in each direction here. It is centered at the origin. This one is also going to be a dotted line because it's less than 4 there. For this one, I can use the point 0, 0 as a test because 0, 0 is not on that circle. And so 0 squared plus 0 squared is less than 4. That is a true statement. So I go ahead and shade the inside there. And this means that for my final answer, it's going to look like the following here. You have this circle, you have this line coming straight through the middle, and this part right here is the overlap where it's both red and blue, and that would be your final answer.